So these are just a little examples of prime numbers, and we'll go over why they're prime numbers. And I bet you're a bit more confused because you're thinking, wait, I thought prime numbers were even, but they're not. So prime numbers are whole numbers greater than 1. Now, whole numbers just means that there's no decimal or fraction, so it's a whole number. Number 1 is not 1.5, 1.8, or 1/2 or 1/12, right? It's just 1. That makes it a whole, or sometimes you might hear natural number. So they're whole numbers greater than 1, meaning it has to be greater than 1. So prime number 1, okay, but what else are prime numbers? So we said 2 is a prime number. 2 is a prime number because it's a whole number greater than 1, right? 2 is bigger than 1, and it's a whole number. There's no decimal or fraction. So 2 is greater than 1, and we'd show that like this. We'd do 2 is greater than 1. That's how we write that. If it was less than, if it was less than, you'd make an L. If the symbol makes an L, it means it's less than. If it's flipped like this and makes a backwards L and it does not line up, it means it's greater than, okay? So this means 2 is greater than 1. So is that rule true? Is 2 a whole number? Yes, 2 is a whole number. And is it greater than 1? Is 2 bigger than 1? Yes. So that's true. We got that first rule. Now, the only factors of 1 in themselves, meaning I can only multiply or divide 2 by 2 or 2 and 1. I can't get any other number to be divisible or multiplied by itself or another number to get 2, meaning 1 times 2 equals 2. 2 times 1 equals 2. Okay? 2 divided by 2 equals 1. And 2 divided by 1 equals 2. So those are the only factors. I can't multiply 1 and 3, right? So that doesn't equal 2, right? So there's no other numbers I can multiply. That's what makes it prime. Not because it's even, but because there's only factors of 1 and themselves. Factors meaning it can only be multiplied or divided by 1 or itself. Okay, so prime examples or prime number examples, okay? 3 is also prime. 3 is prime. Why? Okay, think, what is the rule for prime numbers? Look in your notes that we just did before if you're still confused. So the rule for prime is they have to be whole numbers. Okay, is 3 a whole number? Is there a decimal or fraction? No, so is 3 a whole number? Yes, 3 is a whole number, so that meets one rule. Our other rule for prime numbers is that there's only factors of 1 and itself, meaning I can't multiply anything other than 3 and 1 in order to get 3. So, is that true? Can I multiply 1 and 3? Yes. 3 and 1? Yes, which still means it's 1 and 3, right? And can I multiply 2 times 3? No. Can I multiply 2 times 1? No. So that means I can only multiply 1 and 3 or divide. If I did division, it'd be 3 divided by 3 equals 1, or 3 divided by 1 equals 3. I can only multiply or divide by 1 and itself, which in this case is number 3. Does that make sense? So 3 is prime because it's a whole number. There's no decimal or fraction. And because it can only be divisible by 1 and itself, meaning number 3, can only be divisible by 1 and itself, meaning that there's only 2 factors, 1 and themselves. That's our rules. So 3 is prime. Let's do some other examples. Try this example. 17 is and why. Think, what are our rules for prime numbers, right? What are our rules? Go back and look. They must be whole numbers. Is 17 a whole number? Is there a decimal or a fraction? No. 17 is a whole number. It follows one rule. So what's our other rule for prime numbers? Is that it can only be multiplied or divided by 1 or itself. So its only factors are 1 and 17, or 1 and themselves, right? That's our rules. So in this case, 17 is prime because 17 is a whole number that can only be multiplied or divided by 1 and itself, or 1 and 17. So 17 is prime because it's a whole number, check, and the only factors are 1 and themselves. So in this case, which that is true, so in this case, yes, 17 is prime, and the factors of 17 are 1 and 17. Because, take it a step further, how do we know this? Because I can't multiply anything else besides 17 and 1, or divide by 17 and 17, or 17 and 1 in order to get 17. Meaning, I can't multiply, oopsies. Let's see, 4 times 4 is 16. So what's 4 times 5? 20. So there's no 17 in the middle there, so I can't get it that way. All right, what about 3? Maybe 3 times, let's do 3 times 4 equals 12. Okay, that won't work. What about 3 times 5? 15. Oh, that's closer to 17. Let's try 3 times 6. 18. We're still missing 17. So you can only multiply and divide 17 by 1 and 17, meaning it's a prime number because the factors are only 1 and themselves, and it is a whole number.